Good evening, ladies and gentlemen, and a very warm welcome to the first of hopefully many webinars hosted by the IRTE Ireland North Centre. My name is Michael Hutchison. I am the heavy and light vehicle technical trainer with Transport Training Services Northern Ireland. I've been involved in the automotive industry for almost 25 years and also recently took part in the National Occupational Standards for the maintenance and repair of hydrogen fuel cell and electric vehicles with the IMI. I'm also the Education Officer and Committee Member for the IRTE Ireland North. Transport Training Services is a social enterprise focusing on apprenticeships and career development training specifically for the automotive and transport industries in Northern Ireland, as well as offering career development training such as driver and transport manager CPC, and specialist training courses and consultancy. TTS is the largest training provider of apprentices for the transport and automotive sectors in Northern Ireland, including various vehicle technician apprenticeships, as well as large goods vehicle and passenger carrying vehicle apprenticeships. In addition to this, TTS can also provide dangerous goods, safety advisor and ADR training. And finally, TTS is also the only organisation on the island of Ireland that can facilitate AirTech workshop and technician accreditation. The webinar this evening is going to be looking at hydrogen in the transport sector from a UK and Ireland perspective. This technology is going to play a vital role in helping to achieve the net zero emissions by 2050 and assist with the transition away from reliance on the internal combustion engine. By the end of this webinar, we will have hopefully given you a better understanding of this technology and how it will develop in the future. I am delighted this evening to be joined by Mr. Jonathan Hogan, the Business Manager for Hydrogen Mobility Ireland, and Mr. Mark Welsh, Energy Services Manager with the Energia Group.
Okay, yeah, no, good evening, everyone. So I work for Hydrogen Mobility Ireland, and so we've been established for a couple of years now. The objective for my presentation today is that I'll just really a quick whistle-stop tour of hydrogen. You know, why we're looking at it now, why it's so relevant, and then have a review of what we're doing in Hydrogen Mobility Ireland to try to get that as we try to get hydrogen into the transport sector. So first up, certainly this is a personal view of mine. Hydrogen, it's a story about renewable energy storage. Michael mentioned there the 2050 targets. So this is, stepping back just from the transport sector at the moment, we have to get to this net zero by 2050. And so renewable energy storage is absolutely central to that. There's various technologies that already exist in order to help us to do that, for renewable energy storage. I've got some mentioned here on this chart. So we've got like supercapacitors and batteries. Technology that works, that we know it quite well and can be utilized. But the problem with those is that they don't last. The duration of them is not good for much more than a day, and their physical capacity is limited. So this really is where hydrogen steps in. It can obviously be a zero CO2 fuel and can be stored at massive scales and can be stored seasonally as well. And so as we inexorably move towards further and deeper electrification, the more the need for hydrogen is. So if we go out to 2050, and so, hydrogen is almost a near certainty, it feels to me at the moment. And I think that's particularly the view coming from the EU. So 2020 was, I think for the world of hydrogen, was a very positive year. The EU announced a hydrogen strategy, and in that it set out a roadmap for renewable hydrogen. I think that's the key point to reiterate here. It's renewable, so it's generated using electrolysis, so electricity splitting water into the hydrogen and oxygen. We can get hydrogen from steam methane reforming, where essentially we're stripping it from a methane atom, but that has carbon dioxide emissions attached to it. So that therefore is a problem. Now it could be that carbon capture and storage can help us in that regard, and that's certainly something that hasn't been outruled. But I think as a technological solution, electrolysis is more viable for me than the carbon capture and storage, and it's certainly, is much more scalable, can be used around the world much more easily. So big ambitions announced by the EU of over the next 4 years to install around 6 gigawatts of electrolysis, and that then increases to 40 gigawatts of electrolysis by 2030. I mean, to put that in scale, the 6 gigawatts of electrolysis is close to the amount of electricity generation we have in the Republic of Ireland. So there's significant numbers. Hydrogen is it's a new energy vector. I mean, in some ways you could argue it's the first new energy vector we've had for pushing like something like 100 years. So it represents a massive challenge. You're essentially you're competing against incumbent supply chains that have existed for many years. You're competing against fossil fuels, which are very energy dense and obviously mined and sourced around the world. So it's a tough ask for the sector. But hydrogen, what's fantastic about it is it's very versatile. So it's anticipated it will have uses in industry, in transport, obviously, and then in electricity generation and in the heating space. But where we see hydrogen first getting used initially is in actual fact, certainly in Europe, is on the industrial side, as to replace its use currently in chemical processes, for instance, because that sector already exists. So there's a natural replacement there. Where we next then see it kind of really taking off is in like the world of heavy duty transport and to the likes of buses. And then as we move through the second half of this decade, I think we anticipate more transport being able to be hydrogen to be able to use for more transport, and then the rest of the uses. This chart touches upon just what I was saying there about the major uses in Europe being on the industrial side. And so the chart looks back over a number of years. And so back in 2050 and really through to 2020, you're seeing small scale electrolysis projects. And the majority of them are actually more focused on industrial processes. But then what we see and what we're starting to see announced just in the last number of years is that we're seeing this kind of real significant uptick in the size of electrolysis projects. And not included on this chart, we're actually seeing projects in scale that go beyond this. So here we have this project of 200 megawatts. We're actually hearing reports of potentially projects even up to 500 megawatts. So it's a massive scale starting to get deployed. So it's very much real and is live. So I mentioned that transport will be one of the early movers. And so the question is, well, why transport and not the other sectors? Without kind of delving deep into the economics, one of the ways that we can kind of look at that is to say, well, okay, let's in the heating space, how will hydrogen get used? The incumbent technology that it may have to compete against is, let's say, a gas boiler. It's an efficient piece of technology, with efficiency of close to 90%. If hydrogen is used in the same context there, it's going to have a similar efficiency. If we look at electricity, a combined cycle gas turbine has an efficiency of around 64%. If gas is used, hydrogen gas can be used in the same way in a gas turbine, and therefore it's going to have a similar efficiency. But when we look at the transport side, the internal combustion engine has, certainly for trucks, an efficiency of around 42%, although if that number's wrong, I think the members in the audience will probably know that. But if we then, but how will hydrogen be used in, let's say, a truck? It's going to be used in a fuel cell, where we see an efficiency of around 60%. So we've got kind of an intrinsic advantage there over the internal combustion engine. And then another major factor from a business perspective is that taxes are a major component of the end fuel price. So governments have levers to promote the use of hydrogen, whereas actually in the heating and the electricity space, the taxes are much lower for the relative fuels. So what could the role of fuel cell electric vehicles be in transport? So certainly, if we look at the benefits of fuel cell vehicles, I think, they're well advertised at this stage. It's fast refueling, less than 3 minutes for a car. The Hyundai Nexo has a range of over 650 kilometers. And I think, from a car perspective, that's something that a hydrogen fuel cell car can almost quite easily achieve. Whereas, let's say for a battery vehicle, that is, it's a bit, they can reach that type of range, but it's kind of a bit more of an ask, and you have to have a fairly large battery in the car. The third bullet point there, I think, is very interesting, but it's the point that it leads to no compromise for the owner of the vehicle, will be that a domestic user or an industrial user. The way you use your vehicle today can be pretty much the same when it comes to fuel cell vehicles. So who do we see the earliest applications being for? So it's long range rapid refueling customers, so e.g. taxi fleets. We're seeing projects across Europe where taxi fleets are deploying hydrogen vehicles for that reason. Do you know, if there's cars that are operating, for close to 24 hours a day, that it really has to be, if it's a zero emission vehicle, kind of at the moment, the fuel cell is the #1 solution for that. Heavy duty users, another key area as well. So if we look at the evolution of the market and kind of where vehicles are, so we're talking about fuel cell vehicles being used in transport, being one of the earliest movers. I think one of the slight downsides of that, as we'll see, there are positives in here, is that the evolution of the market, so the rollout of vehicles by OEMs is lagging a bit where ideally we would like to be. But we've kind of have that chicken and egg problem in that obviously the OEMs wouldn't commit to mass production until infrastructure's there, and that's something I'll touch upon a little bit later. So the charts are relatively busy here, but kind of the key takeaways are is that in cars we've had those initial deployments. We've recently had the 2nd generation Toyota Mirai released, and so that's we certainly on a Toyota relative to a Toyota vehicles, it's not a full industrial scale relative to those, but the production certainly is starting to ramp up on those, and then there are other OEMs that have committed in the car space as well. Again, we're seeing vans, we've had early demonstration projects, and we're starting to move now into that early commercial phase. And just I think it was maybe last week or the week before, there's another announcement from Renault with a commitment on the van side. We've got a reference to China there. China is a very interesting area market to look at because they were early champions of battery vehicles, but they're also actually quite heavily championing fuel cell vehicles as well. So certainly it's a market to keep an eye on. Looking at trains, we've got demonstration projects underway at the moment. Next couple of years, we'll be moving into that early commercial phase. And again, then it's more mass market by the middle of the decade. On the buses front, again, we've had, we're certainly at that stage where we're in the early commercial phase. We've had across Europe, there's been a good rollout of fuel cell buses through this Drive project. Single decker buses, and just recently, 2 manufacturers, Brightbus and Alexander Dennis, either have or are committing to double decker fuel cell buses. The double decker is a bit, it's not something that's widely used across Europe, so it's quite almost island and GB centric, but so it's important to have those vehicles because certainly the bus operator in Dublin intends to continue using double decker buses, but so those buses are arriving, and Mark Welsh will be talking certainly about that later. Trucks. So trucks are a very important area. I think if you look at any of the literature around fuel cell vehicles, trucks are often perceived as going to be the key movers, and that's where the big economic advantage for fuel cells comes in, because of the way that they scale. Whereas, you know, battery truck, the battery is such a significant component, the weight increases, and so your payload is less. And, you know, that's certainly an area that we in Hydrogen Mobility Island see as being very important. The slight downside is that we're still away from the true, you know, mass market position. We've got Hyundai has a demonstration project underway in Switzerland at the moment, a pretty impressive project. And recently, and sorry, it's not on this chart, but Daimler announced its hydrogen fuel cell truck, but that's not going to be delivered to customers until 2023, with more mass market deployment from the middle of the decade. This chart, just very briefly, it just shows you the reduction in prices of buses, because, you know, buses have been the key area where we have actually seen fuel cell vehicles deployed. But, you know, if you go back just over 10 years ago, you're spending more than €1 million for a single decker bus. That price has come down substantially, and from conversations with OEMs, we would you know, anticipate in the next couple of years that coming down to €350,000 per bus, which, you know, makes it more attractive. I was hoping to get a total cost of ownership chart in here from work that we as Hydrogen Mobility Island undertook, but I wasn't able to, unfortunately, for commercial reasons. But I've sourced this publicly available total cost of ownership calculation from the McKinsey Centre for Future Mobility. And so there's quite a lot on the chart, but if we just focus in on this third chart here, there's 3 lines on the chart. The line that is progressing upwards, that's the internal combustion engine. So as we understand today, that's the cheapest form of vehicle on the truck's side of things, you know, with a range of 600 kilometers. But then they anticipate that by the end of this decade, fuel cell vehicles will become commercially viable relative to internal combustion engines. And we actually see that they anticipate that fuel cell vehicles will have a lower overall total cost of ownership relative to battery electric vehicles. I mean, one can make the argument that 2030 and beyond, the total cost of ownership of diesel becomes kind of a bit meaningless if countries aren't permitting their sale. Now, so in the interests of being kind of even-handed just on the total cost of ownership, I've got a chart here which shows another total cost of ownership, but this time from the International Council on Clean Transport. Just the 2 bars to focus in on this one, on battery electric in 2030, and we'll compare that with the hydrogen fuel cell in 2030 as well. And on that basis, these are for long range trucks. They're saying that actually the battery has a lower overall total cost of ownership. The point I want to raise here, though, is that there's no total cost of ownership calculation. It very much depends upon your fleet and, you know, how you as a company may operate. If your battery electric vehicle only affords you, let's say, 600 kilometers of range, whereas you can get a hydrogen fuel cell truck, which Daimler is anticipating, of 1,000 kilometers, you know, and you're operating a fleet of 100 vehicles, it might be that you have to buy less fuel cell vehicles than you do battery electric vehicles. So that massively sways the argument as well. And I think one thing I would also challenge about this is that they have the cost of electricity falling to 2030. And I mean, this is a personal view, but I cannot see how the price of electricity can fall over the course of the next decade, given the storage requirements that we're going to have to put into the sector, and you know, making the grid stronger to be able to accommodate everything that we want to do. So, but you know, there's no right answer, but really it's something that has to be looked at by individual companies. So to touch upon Hydrogen Mobility Island, we're a group of 12 commercial members. We have a range of backgrounds. The companies have a range of backgrounds, from wind energy operators, utilities. We've got car companies in there, and you know, forecourt operators as well. We have representation in the group by government departments, both in the Republic of Ireland and Northern Ireland. So they join us on our steering group meetings. It's very important to have them there, because I think for all that I've talked about before, without government policy support and without financial supports, the industry doesn't take off. We're competing against these incumbent industries. We have to have that support. And it's not, we're kind of calling for supports that we've seen from, battery vehicles, for instance, and in other parts of the energy sector. Slide on our mission, but I mean, in a nutshell, our mission is that we want to see hydrogen fuel cell infrastructure and vehicles develop in Ireland. So as part of the first phase of work that we undertook, we did a mapping exercise with some consultants, looking at how we could get a decent level of national coverage up by 2025, and this was the plan that we came up with. So we're looking at kind of clusters. So over the next couple of years, a cluster in Dublin, as we see here. Then as we progress 2023 to 2024, clusters in Galway and Cork. And then in the second half of the decade, as trucks start to come in, then we'd be looking to kind of to get infrastructure on the trunk roads to enable that national coverage. It's a busy chart, apologies for that, but it really is to say we extended the work looking out to 2030, and we came up with a number of 76 hydrogen refueling stations required to then increase that scale to give us kind of complete national coverage. So I suppose there's two ways of looking at it. It sounds like a lot of stations, but then when you compare it to the number of stations, conventional refueling stations in Dublin alone, 170, the number kind of puts that into relative comparison. To quickly touch upon the first deployment project that we were proposing, it's in Dublin. We're looking at the numbers, let's say, of around 30 buses, 60 cars. So this is a plan. This is a plan and a proposal that we would like to see undertaken. It would require investment of around 35 million euros, and we would hope to have government support in order to accommodate that. But that would get us 3 hydrogen refueling stations. And the reason to go for 3 hydrogen refueling stations is that we've seen elsewhere across Europe, single hydrogen refueling stations. But the problem with that is it doesn't create a market that you can grow off and expand upon. But so I suppose if you get the 3 in, it's a cluster. It gives fleet operators, it gives bus operators confidence that there is going to be that supply there. So it's kind of, rather than going in at demonstration scale, it's trying to go in just a little bit beyond. Just conscious of time here, so we looked at costing everything out to 2030. Bottom line, we require investment of 350 million to develop what we're looking at, which I think is an achievable figure. It's a number, but it's an achievable figure in our view, and we think the investment can be done. I haven't really touched upon kind of like the cost of fuel, but we do think we could be getting our cost of fuel below 10 euros a kilogram, which is kind of a key level. But fundamental to it, though, we would want support for green hydrogen, which effectively then would lower that cost of hydrogen, the specific number to be determined, and obviously then on a sliding scale as we move out across the decade. Just to touch upon, I wanted to touch upon the structure that HMI is operating to. So this is a working group structure that we've instigated within the group, and so the reason for showing it is to show you, what has to develop in order to develop the hydrogen for mobility. So that, there are these 4 components: production, refueling, and vehicles. And so there's a circle here, and at the moment, we don't have any certainty at any point in this circle. No one wants to produce because there's no refueling stations, and no one wants to buy vehicles because there's none of the above. So what we really need is an injection of certainty. Now, through our conversations with potential producers and vehicle owners and users, like, the will is there on the production side, and like, people are absolutely interested in it in terms of operations. But the refueling stations is the hardest piece to get away, because, you know, from a cash flow profile perspective, I think they carry more business risk because you have to overscale those relative to the other components. The production and vehicles can be constructed so that they very much kind of meet each other, but the refueling station has to be outsized in order to accommodate those. So like for Hydrogen Mobility Island, the biggest challenge we face, and we're seeing this across Europe, is how we can build this network and how we can get that structure in place to build the refueling stations. So, and then lastly, though, we have got hydrogen vehicles in Ireland at the moment. Thanks to Hydrogen Mobility Island, we were able to bring this trial bus in, and that's operated successfully over the last couple of months. And we've got 3 more buses being deployed in a trial deployment in Dublin, and that's going to be starting soon to be looking at, you know, and then looking to expand that further. So the buses have been with Bus Éireann, which is one of the bus operators here. And, you know, the engineers are kind of working closely with this, and they're, you know, doing great work and really starting to understand how this could be used, they could be used in fleets. So that's it from my side of the presentation. Michael?
I would like to now hand over to Mark Welsh, please, for his presentation. Thank you.
Oh, well, good evening, everyone. I just hope my presentation came up okay. I'm just going to chat. I've been asked to chat about, or give a presentation on a case study of the work that we have been doing in delivering a hydrogen refueling station. Going to deliver electrolyzer and buses into Belfast. And I'm going to start with just a look at Energia, what we actually do, and then we'll be looking at renewable energy in Ireland and what we're trying to make it more efficient by using it at times when it's switched off, and I'll explain that. I'll explain that shortly. I'll just have to move things about here. Okay, so as part of the Energia group, we are electricity utility. We're all island. We're both north and south. We are an offshoot of Northern Ireland Electricity in the 1990s, and we have developed a company. We have moved as the first independent supplier into the Republic of Ireland. And as you can see, we have about 750,000 customers. We have a power station with a capacity of 747 megawatts. And we have wind assets in total of about 1,800 megawatts. So to give you an idea of the scale, we have about a third of the market in nearly all areas. The biggest player, obviously, in the island is the ESB. And we as a supply business would be about a third. We have about a third of the renewable assets, about a third of the customers, so we are a reasonable sized player within the island of Ireland. And we are making investments into renewable. We've already invested $1 million, and we have a £3 billion investment plan. And that would include things like more onshore wind. We'll be looking at offshore wind. And as you can see, we have another redigestion plant. And of course, recently we've been looking at renewable hydrogen. You know, we have bought into the net zero, and we've bought into the targets. And the targets are that by 2050, we'll be carbon zero neutral. And we'll be trying to ensure that no CO2 is emitted into the atmosphere. You know, we want to build on this success. You know, I'm going to show you in a second, but we have been successful in building up our renewable assets within the island, and we're moving towards 50% renewable energy. And I'll have a graph to show you exactly where we are. And we do believe that hydrogen is a key new energy vector that we can use. We can use this renewable energy to create another fuel that can go into other sectors such as heat and of course in transport. So just to show you where we are with renewable assets, and you can see I've shown some renewable generation for Northern Ireland, and you can see that we have built up from a low base. In fact, when they started in the year 2000, our target for 2020 was to deliver 12% renewable. So we were sitting as an island. We knew we couldn't have a reliability on a large, like the whole of the GB, a large network that could take additional renewables. So our target was given to us of 12% by 2020. And you can see by 2020, we are now sitting from October 2019, that's 2020, September 2020, we're sitting at now on a rolling average of 47.7% renewable. So it's a real success story that we have been able to build our renewable assets, and something that we should be really proud of. You can see here that there is almost a 50-50 split between non-renewable, our gas and our oil stations, and our renewable energy. And to give you an idea of in Northern Ireland what that actually looks like, you can see the vast majority of the renewables is from wind energy, at almost 85%, followed by some landfill gas, biogas, and solar PV. And as a business, we would like to expand in each of those areas. But that does come with a problem, especially because we've got a lot of wind assets. We all know the wind doesn't blow all the time, and our system cannot cope with renewables only, because we need the big gas or oil plants that carries the inertia. So if there's a major fault, all these wind turbines can't ride through the fault the way that a gas turbine can. So we have to be very careful the way that we operate the system. So it does mean when there's a lot of wind and the load starts to drop, we have to turn our renewable assets off. It's just the way that we have to operate the system as we are at the moment. That's why you'll hear a lot about batteries and battery storage. Battery storage is going to be key to get more renewables on. But at this point in time, all we can do is turn the wind assets off at times of high wind and low demand. And this means, and this is called curtailment or constraint. And it means that we have an asset sitting there and we can't use it just because of the nature of the system. So we're losing out on a lot of energy. And that's when we got involved in the GenCom project. I'll just give you a sort of brief overview of the area. What we were trying to do was capture this times of curtailment, times when the wind assets are being switched off, and then use that energy and put it into another energy vector. And that energy vector was hydrogen. So we would take the electricity that was going to be switched off anyway. We'd use electrolyzers, use electricity to run the electrolyzers, and the electrolyzers would produce the hydrogen. And so all you have is your water getting split into the hydrogen and oxygen. You store the hydrogen or you put it into pipes in the ground, and then you can use it for various things. So the GenCom project was an Interreg funded project. It was £9.2 million. We had 3 pilots, and being a European project, you obviously have to have partners, and it has to be cross-border. It has to involve other countries. And we ended up having 3 pilots. We had a bioplant in Stornoway in Scotland, and they were using anaerobic digestion to the hydrogen, and using it mainly for heating. They also had were using the oxygen from the system as well, because they were able to feed that into their fish farms, and that would help the growth of the fish. In Germany, we had solar to hydrogen, and that went into feed cars, and it has went very well. The plants are delivered, they're installed, and they're working well and giving us a lot of good data and information to show how we can connect them to large scale wind farms. And then in Northern Ireland, we have our wind farm to hydrogen, where we're going to be storing an electrolyzer on a wind farm. And the idea was to pull all this information, all the data together. We would look at how we did it technically, we would look at how we did it commercially, and so we would have all the costs and all the information that was needed to come up with a final deliverable, which is called a decision support tool, which when you go on, it'll have all the information that if you had, say, a wind farm with, say, 250 kilowatts, it would show you how much hydrogen that you could get from it. It would show you how much it would cost to install. It would give you information and ideas of who you would talk to, and that would be start of your business case of looking to see, using the information we have, that it could work for you in your particular area. So it's been a very successful project. We started it 5 years ago when people thought we were mad, and then now we're seeing it just as we're coming to the end of it, and that we're seeing that hydrogen is moving forward. So just going on to our particular case study, and I called it the Wind to Wheel project, and that is to supply hydrogen buses within Belfast. And actually, it's split in two sections. We have the GenCom project, and that is our wind farms connecting an electrolyzer to produce hydrogen, and we store that in trailers. And then the second part, which is funded by the Office of, it's now Zero Emission Vehicles, where we're going to install a fueling station within TransLink site in Belfast and bring 3 double-deck buses to Belfast. I just want to just let you know exactly where we are on the project at the moment. So the first part is the electrolyzer. I have to be honest and say that we have been hit by COVID. Everything should have been in and finished in this month, but there has been a delay. So we are anticipating that we will have the electrolyzer unit delivered in late March, and it'll probably take about 2 or 3 weeks to have it installed. So we're hoping that by the end of April, we'll be up and operating with the electrolyzer. Things are going well from it. We are going through all the safety processes at the moment. We're looking at our HOSUP. We've appointed electrical contractor. Our civils engineers have commenced. They've got the berm in, and they're starting to work through everything else which is required. So it's all hands on deck at the moment to get ready and then to receive the electrolyzer. And as I say, we connect it to the wind farm and we just add water. And this unit will split the water, store the hydrogen, and then we can use that, as we'll see in a second. It's a very basic layout. We'll have a high voltage transformer connected through a high voltage switch from our wind farm, and that just supplies the electrolyzer unit. That will go into, it will feed a compressor to take it from 30 bar up to 350 bar, and then our compressor will fill the trailers. And these are our trailers. So our trailers have actually arrived. We are using them. We haven't got an electrolyzer to fill them with hydrogen. So we're at the moment filling them in Aberdeen, and one of us is going to go down to Dublin to get filled. We are using them to fill the buses that are there at the moment. And I would say that whenever we were looking at developing the project, one of the things that we did say is that, look, rather than putting a new hydrogen pipe in and piping it miles, from the electrolyzer from the wind farm and down, why not use the infrastructure that's there? We already have lorries. We have got trucks. We can use the guys that are already driving trucks about, and we can replace a diesel truck with a hydrogen truck. And that's what we're doing at the moment with our partners at Petrans, who have been so far excellent in picking our trailer up and bringing it over and storing the hydrogen for us. So we're interested in seeing that we can get this business model to work, because so far it has worked really well for us. So we have got it's only 3 trailers, but they have arrived, and we are using them. Our partners, TransLink, they came in partnership with us, and they decided to go initially for 3 buses to get them trial. The 3 buses have arrived. Again, they were slightly delayed, but did come in December, and they have the buses. They're now on the road. They're using them just to fill in at the moment, and for driver training. And early indications are that they're working exceptionally well. They're quiet, they're fast, they're doing everything that they're meant to do, everything they say on the tin, and it's a smooth ride. And so far, there has been no complaints from the drivers, apart from it's very quiet and they can hear everything. So if there's a little buzz or not, they can pick it up, because you just can't hear anything on the So because they were so quiet, they're actually retrofitting and putting in an audio sound system, where they actually will be sending out a noise at low speeds until they get up to about, I think it's about 20 miles an hour, when the road noise will take over and people can hear the buses coming. But if they're sitting at 10 miles an hour down Royal Avenue, you can't hear anything. So they have this sound being generated, so that it's a safety feature within the buses. The official launch did happen on the 16th of December. That's Chris from TransLink. That's our chief executive. Buddha on the left from Right Bus, and of course our minister for the Department of Infrastructure. So it was officially launched. They are here, and they are working quite well. Our fueling station, as I'm going to share in a minute, is not connected yet. So we are just we have a temporary system in at the moment where we're feeding the buses from the trailers, and but so far so good. There's a lot of work to be done. You know, the workshops need to be modified. When a bus comes in, you have to make sure that if there's any leak of the hydrogen, you have to make sure that there's nowhere for it to get trapped. So they're working on the workshops at the moment to make sure that they have the correct lighting and the ventilation and the safety procedures all in place. And we are actually working on training and transport training services. There has been a lot of discussions. We are looking at trying to develop some training programs. They are well ahead of the race, and they are looking to introduce training for mechanics for, first of all, introduction to hydrogen safety, and then working on electric and a fuel cell vehicle. So all of that in the background is taking place. As well. I've already mentioned TransLink are doing their engineering training and also their driver training, and making sure everyone is up to speed. The fueling station, again, it's funded by the Department of Transport on their Office for Zero Emission Vehicles. Again, it should have been here this week. It has been delayed. It'll be here in March, but first fix is complete. The problem that they had was that the electrical crew was taken down with coronavirus. So that was a bit of a hold up, but they are going through, the wiring's completed, and they're going through their testing phase at the moment. And so far, everything is looking well on getting the station ready for the buses going into full-time operation, hopefully as soon as our lockdown is over. There is a transport survey that the Dublin City University is doing. It's something that you're opportunity to get involved in. They're looking for up to 200 companies to respond to the survey on potential hydrogen transport for the future. So I'll not spend too much time on it, but I'm sure we'll send out copies of the presentations, and you'll be able to access that survey. It's, you know, we can send the link out to everybody. I'll just take a couple of seconds just to say that not only are looking at bus and road transport, but we're also looking at marine as well. And there's an exciting project in Belfast led by Artemis Technologies. It's a £60 million project where they're taking the technology from the America's Cup. And the America's Cup, what they're able to do is build a ferry on a hydrofoil. So it's like a T, it's like an upside down wing. And when the ferry gets up to speed, it comes up on the hydrofoil, goes above the waves, and it's a very smooth ride, and it's very efficient, obviously because it's only the hydrofoil going through the water. And as you can see here, it is driven by a propeller, which is a Formula One motor. So it's an electric driven ferry, and it's going to revolutionise, we think, the marine ferry industry. They are building the first one in Belfast here, and it's going to be a water taxi between Bangor and Belfast using this new drivetrain. It's an exciting project. We hope that it'll secure employment in Bombardier, where they will be building. It's just like a water wing, if you like. They will be building the hydrofoils. We'll be looking for the likes of Harland and Wolff to fit them and retrofit them, and hopefully that they can get be able to manufacture some of the vehicles as well. And of course, using the hydrogen from Energia. Well, initially it'll be a battery operated, where we'll be providing the chargers, but we'll be moving into hydrogen, so we can get a better range on the unit. So it's a very exciting project which is coming up and showing that there's other areas. There is a question that came in and saying, look, can hydrogen be used for domestic and for other types of heating? And well, yes, it can. We can see that there'll be a large scale hydrogen production going forward, and it's going to be mainly driven by offshore. And so the offshore electricity coming onto site can then go into hydrogen production. This can be stored in pipes. It can then go into the natural gas pipework. It can be blended with the natural gas pipework, or it could be 100%. We're hoping that it's going to be a good blend, and then that can be used for household heating, cooking, and industry. So thank you very much, and I'll hand back to Michael.
Thank you very much indeed, Mark. Very informative information there. We're just going to take a few questions now. If bring them up here. First question is, could hydrogen be a replacement fuel for domestic gas boilers, where there need to be much alteration to current storage systems? You may have touched on that there, Mark. That question's from Adam.
Yeah, I did touch on it. Seeing that it came in, but I had two meetings today actually. One was with our gas network suppliers, and they are currently looking at projects to see how they can get hydrogen and how much hydrogen they can get into the gas network. It will include obviously the metering, because you have to meter hydrogen completely differently than what you do natural gas, and we'll also want to look at the appliances and make sure that they operate within hydrogen. Okay, there needs to be legislation in place. There needs to be legislation to say that a boiler has to be dual fuel, has to be able to take natural gas and hydrogen. When that legislation comes in, all boilers will be upgraded.
Thank you. Next question is from Glenn. With the UK having completed Brexit, is there an impact to the UK hydrogen fuel development and its use now that we're out of the EU community? And is there potential for any additional costs to the UK market, or do you see very little impact?
From my point of view, the UK government has focused on hydrogen. The Northern Ireland government is following suit. There is going to be £500 million available for hydrogen development. They'll be looking at all areas, electrolyzers, they'll be looking at fuel cell development, etc. In Belfast, there could be an electrolyzer manufacturer coming very soon. While we get that level of support, similar to what support there is in the EU, I think there won't be any impact, and they will keep moving forward with hydrogen development.
A potential advantage of being outside of the EU is that you remove yourself from state aid rules. So that could be a benefit to promoting certain industries. But some of them I actually see in Europe as well, though, is that there is a process now called, it's called IRTE, but don't worry about what that's called. But it is actually a way, like, the EU is recognizing that state aid is a problem for some of these new and emerging industries. So it kind of levels itself off, shall we say.
Thanks, Jonathan. Another important question here, which I'm sure is what everyone's thinking about: what will be the comparison price between diesel and hydrogen?
Yeah, certainly Hydrogen Mobility Ireland, and Johnny can comment on this, has shown the costs and how they will come down as it develops. We would say that if we can hit £10, that'll be equivalent to £10 per kilogram. That'll be equivalent to the diesel price. There is support at the moment through RTFO certificates from the government, which is worth £7.55. We think we can, with that certificate, we can get to match the price for the final customer cost, but we'll be looking for those as the technology comes on, as it gets more into production. You will see the cost starting to come down, and we'll be pushing to try to get below that £10.
Yeah, I mean, that'd be something similar, yeah, from us. The total cost of ownership calculation is relative, because, I mean, you can line up the cost of diesel with the cost of hydrogen, but obviously if the hydrogen vehicle is more expensive, then it can offset the kind of the fuel parity. And so when it comes to trucks, no one drives a truck for fun, so it is a business decision. And we did look at, so it depends on the type of vehicle, what price of fuel is acceptable to you. But we did do calculations in Hydrogen Mobility Ireland, and don't know the precise numbers off the top of my head, but once you get to like €7 per kilogram for certain, for, like, say, I think it was for vans, for instance, it becomes, you're happy to take that level. So it may be therefore that we need, so we would need subsidies to bring us down to that level.
Thank you.
But sorry, just on the precise number, don't quote. I would have to just look up the actual number. I don't know off the top of my head. I'm sorry.
The next question is from Alan. How easy is the refill process? Thinking of when the public would start using hydrogen in their cars.
Do you want to take that one, Mark?
It's going to be very similar to just filling a truck. You'll just come along and connect the nozzle, and the gas will be dispensed. We haven't got the fueling station in as yet, but certainly we were able to fill a bus within 9 minutes from the temporary system. So
a very quick turnaround.
Yeah.
It really is. The point being, for users, it's just like having a conventional car in that regard.
I'm just conscious, everyone. I've got a lot of questions coming through. I'm going to try and get through as many as I can. Next question here: when we are looking to see hydrogen technology and light vehicle technology, and when it does, how safe and easy will it be for members of the public to fill up compared to petrol and diesel? I suppose the question is, how user friendly is it to refuel?
Yeah, I mean, around hydrogen safety is something that people always comes to mind naturally enough. In terms of getting hydrogen refueling stations constructed, we're doing work. We're looking to do some work with local councils to say, well, if we were putting a hydrogen station here, what, looking at the permits and everything needed. That's very kind of on the like, let's say, the health and safety side. And there are certain rules that have to be adhered to if hydrogen was going onto an existing forecourt where there's diesel and petrol. You have to have certain sightlines and various details. But yeah, I mean, it's just from a consumer perspective, it's very much plug and play. So hopefully we can have good standards so it is completely on because it has the same connections. I mean, it's a very high pressure 700 bar, but it's gone through rigorous testing regimes. And I think if we take BOC, I think, roughly speaking, they operate close to 200 hydrogen refueling stations across the globe. So it's a tested technology.
And question from Steve: any feel for the life of a typical fuel cell? And secondly, are you reliant upon any rare earth materials?
Yeah, this is something that is still being kind of, I suppose, being tested in the wild to a degree. I know the number a bit better on the it's the analogous of a fuel cell, but it's in the electrolysis fuel cell stack. And I mean, they currently OEMs of those would quote 40,000 hours before replacement is due. But I think realistically, we would anticipate that would be probably closer to 60,000, which is what they were kind of suggesting would be in a number of years. So it's a fairly decent operational length. It's that almost being the that can be a straight replacement later on in the vehicle's life as well. That would be anticipated if that's needed.
And a couple of questions coming through on the same subject of the possibility of using wave power as well as the wind power. Is that something that could be in the future?
Yeah, there are a number of bodies working on it. CASE, for example, at Queen's and the Biden Centre. So that technology, it is way behind wind, but it is coming forward. The advantage of wave, if we could get that right, is it's predictable. You know when it's going to happen, and it'll be there most of the time. So it's not like wind you're relying for the wind to blow. So it is going to be a lot more predictable, and certainly when that develops, that will be a great asset to getting us up to net zero of electricity. So it's in its infancy, but they are working on it.
Thanks, Mark. And I think just for time, I think we're going to wrap up with one last question. This is from Chris. Is there a difference in cost when a hydrogen vehicle is to be disposed of when it reaches its end of life compared to that of a diesel? And what is the environmental impact when disposing of an end-of-life hydrogen vehicle?
I don't know the precise definitive answer to that. A hydrogen vehicle is lighter than an internal combustion vehicle, so I'm guessing as a result there's less metal included in the overall vehicle as a result. I guess there's probably people on here who better understand kind of the supply chains of the recycling and so on, but it's something that will have to be dealt with and it would have to be recycled. But I mean, I think there is value in that. I think maybe as Mark touched upon the bus being so silent in its operation. I mean, maybe in 10 years' time, do we see the actual wear and tear on the electric buses is less? Because we do anticipate that the maintenance cost as they roll, as this technology develops, will be less. So you've got an intrinsic advantage there. And sorry, actually, it was the rare earth metals question. I mean, so the key platinum is a large component of fuel cells stacks at the moment. So that's something certainly you'd want to recycle, and hopefully that future technology could evolve to bring that down. And so, I mean, fuel cell technology is very mature, in fact. But I mean, fuel cells have been in operation for, you know, almost 100 years now in various different guises. But there's still a leg for them to go, for them to improve.
Great. Thanks very much, Jonathan and Mark, and thank you very much for presenting this evening. I think we'll be bringing the webinar to a close. I would just like to thank everyone for joining us this evening, and I hope you found the webinar informative. If you do have any additional questions, please do feel free to contact me on LinkedIn. I do apologize if I didn't get around to answering your question this evening, but I think it's one of those subjects that we could talk about all night. It's very interesting. But again, thanks for joining, and I'll talk to you soon. Thanks.
Thank you, everyone. Pleasure.
Thank you, everyone.